Hello everyone! So we are starting with a brand new unit. So let's all open up to Unit 5, which we're going to be dealing with operations on rational expressions. A lot of cool multiplication, division, subtraction, addition, things like that we're going to be doing for this unit. So let's open up to page 1. All right, so today we're going to begin with multiplying and dividing rational expressions. So these are things that we did learn in Algebra 2, but we're going to do it as review. So I'm actually going to skip the do now, but I do want to take a look at our first few questions here. So how do you multiply fractions, and can you give me an example? All right, yes, I see your hand raised in the very back. Very good. So the way that we multiply fractions is by multiplying across. Not cross multiply, multiply across. So an example we could take a look at is something like 1/2 times 3/4. You multiply across. 3 times 1 is 3, 4 times 2 is 8, and there you go, 3/8. Okay, there are a bunch of examples that we could have came up with. What is the trick now if I said to divide two fractions? So what if I said divide 1/2 by 3/4? Okay, we got to remember to do our keep, change, flip. Keep, change, flip. So now we would be looking at something as keep the 1/2, change division to multiplication, and flip the 3/4. And again, multiply across. We'd get 4/6, which simplifies to 2/3. I could have given you something more complicated. Okay, with our keep, change, flip. I could have given you something like this. X plus 1 over 5, all divided by x plus 2 over 10. Keep the x plus 1 over 5, change this division to multiplication, and flip the denominator. So now, this is what I'm looking at. Multiply these, and we'll see things that cancel. Well, not cancel, simplify or reduce. We can simplify this into a 1 and this into a 2. There are no terms in common here or here. So we would rewrite this as 2 times x plus 1 all over x plus 2. And that would be simplified completely. How would I simplify example 3 here? Well, we break this down into pieces. You could break it out like this. You have 3 over 15, a to the 5th over a squared, b squared over b to the 8th, and c over c, right? Break them up into pieces. Well, 3 over 15, we can really divide this by 3 and this by 3. So you'd have 1 over 5. So I'm going to rewrite that. 3/15 is 1 over 5 times, when you divide like bases, we subtract the exponents. So a to the 5th divided by a to the 2nd is a to the 3rd. B to the 2nd over b to the 8th, again subtract the exponents, you'd have b to the -6th, and c over c is just 1. So if I want to write this with all positive exponents, we'll have a cubed on top, 5 is in the denominator, and b to the 6th, right? To get rid of a negative exponent, we put it in the denominator to make it positive. And there you have it. You'd have a cubed over 5b to the 6th. Okay, let's keep going. Let's take a look at some more challenging problems. So let's bring it over to the second page. You guys could handle those other ones on the other page. Let's take a look on page 2. Let's make it a little bit more interesting here. So now we want to simplify again. We've got multiplication in the middle, but things don't look so simple. So what should I do first? I'm going to want to factor. So let's see. So nothing is going to factor here. Let's simplify. We have a plus 5. Really, that's a plus 5 twice. Because when you have something squared, that means you have 2 copies. Okay. We can factor this denominator. Right? What multiplies to -10 but adds to 3. So what multiplies to -10 but adds to positive 3. We would have x plus 5. Oop, not x, sorry. A plus 5. So used to using x. A plus 5 and a minus 2 times, right, we have multiplied by, let's factor here. Take out a 7, and I'll have a minus 2 all over 14. Now we're going to start to see things that can cancel. Guys, you could only cancel because there's multiplication here. Really, I could rewrite this as a plus 5 times a plus 5 times 7 times a minus 2 all over a plus 5 times a minus 2 times 14. This is being multiplied, right? You guys told me before, multiply across. That person in the back row raising their hand. So we have these are going to cancel, and a minus 2's are going to cancel. And can we reduce 7 over 14? Yeah, that's really just 1/2. That's really just 1/2. So we're left with a plus 5 all over 2. Nothing else can cancel. Don't start trying to cancel things here, guys. Nothing else can cancel, because now you've got addition going on between. All right, before, because everything had multiplication, we could cancel terms, but now we can't. That's our final answer. Why don't you guys try question 4? Remembering your keep, change, flip. Why don't you try question 4? Think you got it? So we have 5k squared over 3h. Keep, changed this now to multiplication. Okay, change this now to multiplication. So multiply, and then flip this. 3h squared over 15k squared. Again, I could rewrite this as 5k squared times 3h squared all over 3h times 15k squared, because there's multiplication between these. We multiply across, not cross multiply. 3's are going to cancel. 5 over 15, that's really 1/3, so I'm going to make this a 3. The k squareds are going to cancel. I have h squared over h to the first. 1h will cancel. And if you can see, we're left with an h on top and a 3 on bottom. So I'm left with h over 3. Now just be careful, these can get a little messy. Okay, so I'm going to do letter A, and you should do part B on your own for practice. I'm just going to do letter A, and I'll post the answer for question B. Again, there's just that little reminder, when you're dividing fractions, we do keep, change, flip, or stage, change, flip. However your teachers taught it to you. Doesn't matter. All right, so again, I'm just going to rewrite because I've got multiplication for all of these. I've got 4x cubed times 3y to the 7th times 30z squared all over 9z to the 5th times 10x squared times 8y cubed. Now, just be careful. Don't get into that habit of just, cancel everything, cancel everything. No, you can only cancel things because there's multiplication going on between the terms. Okay, so because I have multiplication going on between my terms, I can look at things to cancel. So let's see. So I have x cubed. Does that cancel with anything? Yeah. So I have an x cubed in the numerator, right? So I have an x cubed in the numerator and an x squared in the denominator. I have one more x on top than bottom. So the x squared's gone, and I'm left with just an x to the first. Okay, so I'm just left with an x to the first, so I'm just going to highlight that. That's remaining. All right, I have y to the 7th over y to the 3rd. Again, I have 4 more y's on top than bottom, so I'm going to make this y to the 4th. So I have y to the 4th. Again, this can get messy, so that's why I'm saying it helps to organize yourselves. I have z squared over z to the 5th. I have 3 more z's on bottom than on top. So the z squared's gone, and I have z to the 3rd. So I have z to the 3rd. So maybe I'll rewrite everything out for right now. So I have 4x times 3y to the 4th times 30 all over 9z to the 3rd times 10 times 8. That's what I have so far. All right, I simplified all of the variables. Now let's see if we can start to simplify the coefficients. So I have, let's see, I have 30 in the numerator and 10 in the denominator. So 30 divided by 10 is 3. Okay, so I have 30 divided by 10 is 3, so there's no more 10 down here. Let's see, I have 3 times 3, which is 9. So these are going to cancel, because 3 times 3 is 9. 9 over 9 is 1. And let's see, I have 4 over 8. 4 over 8 is really a half. So that becomes a 1, and this becomes a 2. So what I'm left with is x, y to the 4th, all over z cubed times 2. That's what's remaining. X, y to the 4th over 2z cubed. Again, guys, this can get messy. Keep yourselves organized. Okay, so why don't you give letter B a try? I'm just going to post the answer. Give letter B a try. Pause the video here. Okay, and that's what your final answer should look like for part B. 5 over 3x to the 7th, y to the 4th. Let's keep going. All right, so let's flip it over to page 3. Let's take a look. We're going to do C, D, and E. We're going to take a look at C, D, and E. This is just, again, more practice, good practice with simplifying rational expressions, right, using that multiplication and division. So here I have division, so we're going to do that keep, change, flip. So before I even do anything, I'm just going to rewrite, keep this, change division to multiplication, and flip this. Okay, flip this. All right. And I'm just going to write one more time. Everything is being multiplied. So I have 9 minus x squared times 4x squared minus 4x all over 2x cubed minus 6x squared times x squared plus 2x minus 3. Everything's being multiplied, so I multiplied across. Okay, multiplied across here, multiplied across here. But I don't like to write those x's. You guys are in pre-calc, we should know. We use parentheses. Awesome. All right, now let's start to factor. I can factor this 9 minus x squared. That's really 3 minus x, 3 plus x, right? That's a dots. I can factor this 4x squared minus 4x. By factoring out the 4x, I'll be left with x minus 1. Okay, let's see. Let's take a look at the denominator. I have 2x cubed minus 6x squared. Right, we always want to factor as much as possible, people. Factor as much as possible. I'm going to take out a 2x squared, and I'll be left with x minus 3. And we're going to factor x squared plus 2x minus 3. And I'll get x plus 3, x minus 1. Guys, all this is just a whole bunch of factoring. And now we're just going to see, is there anything that's going to cancel? And there better be. Let's see. I have x plus 3 is the same thing as 3 plus x. They're the same thing, right? That's the commutative property. X minus 1 over x minus 1. I've got a 2 here and a 4 here. So I'll be left with a 2 on top, no 2 on bottom. I have an x here and 2 x's here. So I'm going to have one more x than I do in the denominator. So that's going to be x to the first, no x here. So let me just highlight what I have remaining. Okay, this is getting a little sloppy. So again, let me highlight what I have remaining, and I'm going to rewrite. Okay, so I have 3 minus x times 2 all over x times x minus 3. Just rewriting. Okay, well, 3 minus x over x minus 3, hopefully you guys remember, it's actually just negative 1. If I have 3 minus x over x minus 3, that's just negative 1, right? That's like me having 5 minus 4 over 4 minus 5. That's 1 over negative 1, which is negative 1. Okay, so that's just going to simplify to a negative 1. It doesn't matter if you put the negative 1 on top or bottom. In this case, actually, I mean, again, it really doesn't matter. But maybe I'll just put the negative 1 on top. And now I'm left with negative 2 over x. So that's my answer for part C, negative 2 over x. All right, now that I showed you part C, why don't you try part D? Why don't you try part D? Again, pause the video here. Why don't you try part D? I'm just erasing so you have space to write. Why don't you try part D? All right, you think you got it? Think you got part D down? Like I said, pause that video. So let's see. We've got multiplication. So this is nice. There's no keep, change, flip here. So I'm just going to rewrite. We have x squared minus 7x minus 8 is being multiplied by that 3x squared minus 4x plus 1. Ooh, you're going to have to do some factoring. Okay, we've got that 1 in the denominator, 1 minus x squared times 9x squared minus 1. So let's see, let's start to factor. Before I do anything else, we should always be starting to factor. X squared minus 7x minus 8. What multiplies to negative 8, but adds to negative 7. And we'll have x minus 8, plus 1, sorry, x minus 8 and x plus 1. Okay, let's see what's going to multiply. Now here you got to do your tricky trinomial. Okay, here you're going to have to do your tricky trinomial. 3x squared minus 4x plus 1. I like to teach this with factoring by grouping, so I'm going to show my work here. Does not matter whether you do tricky trinomial or factor by grouping. I look to see what multiplies to 3x squared. That's going to add to negative 4x. And we'll have negative 3x and negative 1x. Split the middle. 3x squared minus 3x minus 1x, right? Because this is the same thing as this. It's the exact same thing. Plus 1. Take out my GCF of 3x. Take out my GCF of negative 1. And let's see, we group. Let's group. 3x minus 1. And x minus 1 is remaining. So I have 3x minus 1 times x minus 1. So that's going to be what I have here in the purple. So that's going to be 3x minus 1 times x minus 1. Let's see. Denominator, I have 1 minus x squared. So I have 1 minus x, 1 plus x, right? We got dots. And we have dots again. 9x squared minus 1 is really 3x minus 1, 3x plus 1. All right? So there we go. I'm just going to erase what's down here to make some space. You guys can always pause the video, go back if I erase something you needed. All right. And now let's start to cancel some terms. 3x minus 1 with 3x minus 1. X plus 1 and 1 plus x. X minus 1 and x, 1 minus x. That's really a negative 1, right? X minus 1 over 1 minus x is a negative 1. So I'm going to rewrite. I don't like things getting sloppy. So I have negative x minus 8 in parentheses all over 3x plus 1. And you can distribute that if you want, but we're actually done here. My answer is negative x plus 8 all over 3x plus 1. And we are done. Finito. All right, last question we're going to take a look at is letter E. Okay, letter E. All right, here we go. So we need to follow our rules for PEMDAS. Always remember PEMDAS. Multiplication first, then the division in order from left to right. So see how I have my multiplication going on here? Then I have my division. So we need to multiply our two terms in front here. We need to multiply this by this first, then do the division. So I'm going to do what's in blue first. Okay, I'm going to do what's in blue first because that's what PEMDAS says. So let's factor x squared minus 9. That's really x minus 3, x plus 3, times, let's see, 5x minus x squared. Factor out an x, and we'll have 5 minus x all over, let's see, x squared minus 5x. Take out an x. Right, we're factoring out an x. Guys, you want to factor as much as you possibly can. Factor as much as you can. And I've got x squared minus x minus 12. So let's see. I have x minus 4 and x plus 3. So I'm doing this first. Then I'll deal with this. Okay, so we're going to simplify this first. Don't forget, you still got to do this part. All right, let's see. I've got x minus 3 is not going to cancel with anything. But I've got an x here and an x here. And I have x plus 3 is going to cancel with x plus 3. And I have 5 minus x over x minus 5 is just that negative 1. So let's rewrite. This is really negative 1 times x minus 3 all over x minus 4. So I've simplified as much as I could. Now I'm going to multiply it all. Or sorry, not multiply. Well, we are going to multiply. Now I'm going to divide that all by what we're given. X minus 4 over x squared minus 8x plus 16. Don't forget your keep, change, flip. So we're going to keep this, what I have in blue, because right, that was from here in blue, x minus 4. And we're going to change this, multiply now, by flip the denominator and numerator. All over 4. And now we're going to factor. Right, we got to factor this here. Okay, hopefully more things are going to cancel. So I have negative x minus 3 over x minus 4 times, oh, hang on, before we multiply, I forgot, this should say x minus 4. Be careful again. One little mistake, and it's going to mess us up. All right, and we're going to factor this here, which is going to be x minus 4 times x minus 4 all over x minus 4. X minus 4's cancel, x minus 4's cancel, and I'm left with negative x plus 3. That's it. All right, so big takeaways from today, guys. Big takeaways. We're going to do more practice with this also tomorrow in class. Big takeaways. After we multiply and divide rational expressions, okay, you must make sure your answer is simplified fully. Okay, it needs to be fully simplified. Really important. Needs to be fully simplified. And before you start multiplying rational expressions, what should we look for first? Always look for factors or multiples. Okay, look for those factors or multiples. If we can factor, GCF, dots, tricky trinomial, grouping, whatever it is, do that first. Alrighty, we're going to continue with this tomorrow. Hopefully this helped.